So, hi everyone, and welcome back to another live. And today we have two awesome folks from Polygon with us who are going to talk about Agglayer. I'm sure, pretty sure you must have seen a lot of buzz, a lot of hype, a lot of posts on Twitter about Agglayer and their new developer portal which just launched. So, for those of you who do not know what Agglayer is, and for those of you who knows, even we are going to talk a lot about Agglayer and its developer portal today. We are going to talk everything, ins and outs of Agglayer, and how the developer portal makes it easier for you all to develop and build on Agglayer. So first of all, we have Coogan with us, who leads the protocol and research DevRel at Polygon and Agglayer. And then we also have Akshat with us, who is also on the DevRel team at Polygon. So I'll just pass it on to you folks, Coogan and Akshat, so that you guys can greet our audience, give a little bit introduction about yourself, and then we can get into Agglayer and understand what are the problems which are there right now in the space and how Agglayer solves it and makes it easier for everyone to build cross-chain applications. So I'll just pass it on to you, Coogan. The stage is yours.
Awesome. That sounds good. So I'll just do a quick intro. I'll let Akshat intro and then we'll jump in. So as Sahil said, I'm Coogan at Polygon DevRel, and I am excited to be here today. Really excited to show the Agglayer developer portal and excited to walk through all the different pieces that we have for you all, as well as just understanding the basics of Agglayer as well. Akshat, you want to say a quick hey?
Sure. I'm Akshat. I'm a developer at Polygon Labs. So I basically make applications and POCs for you to test out Agglayer. Previously, we had Agglayer on testnet, but now we have something called Sandboxed, which we'll be showing off soon, which will make it possible for you to test Agglayer locally and make a lot of your ideas of cross-chain dApps come true. So very excited for that.
Wonderful. Okay, so first off, this is like the main thing that we want you all to take. If you take away nothing from this live stream today, please go to build.agglayer.dev. It'll walk you through the tooling for doing this cross-chain development with Agglayer. It'll get you all up to speed, give you everything you need. We're going to be walking through this today as well, but I just want to put this at the top, and we're going to be keep on sort of hammering it. Please go to build.agglayer.dev and check out this site, check out the tooling, give it a spin, and let us know how you're doing with it, how it works, all these sorts of things. That we really need developer feedback. So the more of you that can go in there and check it out, the better it'll be. And I think you'll really find it to be super exciting, challenging in a really good way, in a way that will be able to sort of grow you as a developer and add this next tool into your toolkit of interoperability. So yeah, that's the main takeaway here. We can also, I'm going to give just a little bit of background about Agglayer. I'll make this quick because I know that we want to do a lot of coding and we want to actually sort of get our hands dirty with actual material. But we do want to know kind of why we're doing this, why we're kind of going through these different, why we're building these different tools and navigating the tech to make interoperability possible. So essentially, the internet when it first started was a number of discrete protocols. It was sort of all separate internet that didn't talk to each other. You'd had sort of different regional areas or associated with universities or with the government in the United States. It was all totally divided, and you were unable to communicate with other networks. So if you were on the East Coast of the United States, it was hard to communicate with another state on the West Coast of the United States, which made it really hard to do things like send email or make things universal. And it was really labor intensive to get to sort of to hop over those paths. So what ended up being developed was something called TCP/IP, which was a common standard for these different pieces to be able to speak to each other. And now TCP/IP negotiates all different kinds of signals and data that goes across all our internet, and it allows us to be able to do this live stream where Sahil's in one place, Akshat's in one place, I'm in another, but our computers are able to seamlessly integrate and seamlessly talk to each other and be able to do work and build beautiful things. A similar landscape exists in crypto today, where we have a number of networks, layer 2s and layer 1s and layer 3s and alt chains and alt VMs and side chains, all these different sort of chains that have significant volume and significant value associated with them, but it's hard to communicate with each other. There's no unified approach to it. And so we think the solution is Agglayer. which is a cross-chain layer that unifies liquidity, allows for users to be able to navigate across chains, and it aggregates the state of tokens on multiple chains, state on multiple chains, and allows for finality and just a security of the ZK tech that's underpinning the Agglayer chains, and the finality as well that we're posting to Ethereum. And the biggest piece that we are addressing here is this unified liquidity. There are so many different sort of there's TVL that's divided across all these different pools, and so we want to keep them all together. We want to concentrate that and then allow it to be available to users and to applications and to chains as well, so that you don't have to bootstrap. So to get the capital into the network, you can just already tap into it existing there. Agglayer has these different components. We can talk about it. It's in the documentation as well. We won't go into it too deep today because a beautiful part of the Agglayer developer portal is that we abstract away a lot of this complexity. So you don't actually have to worry about any of these underlying concepts. But for those who are interested, we have ZK proofs, which are creating security. We have proof aggregation also through ZK. We have a unified bridge, which allows for standards and fungible tokens. And coming soon is fast interop, which is lower latency between these chains as you're doing these calls. This allows for a lot of really exciting stuff to happen on the protocol level, a lot of interesting primitives that you can play with and build from there. And it makes it really powerful as an application developer and as a dApp developer to be able to take all these different pieces and then build something really unique or really interesting, such as a social app which communicates with another chain that does DeFi, and being able to have those different pieces talk together. We have a chain called Katana, which is a really powerful DeFi chain, and that can speak to another chain which is maybe doing some sort of social fi stuff, and those two can talk to each other. You can trade positions on Katana while you're still on that chain, and Akshat will walk through one of those examples today.
Coogan, I have one question before we move on.
Please.
So I just saw messaging and I was curious that this is obviously not exactly same, but I have seen cross messaging apps. I have seen cross messaging protocols like Wormhole, Layer Zero, all of that. So how is this different than those? And like what more features or what more problems does this solves? Because obviously it's not just limited to messaging. It has shared liquidity. It has like, for example, a chain development kit using which you can build your entire chain on top of this. So if you want to share more thoughts on that.
Yeah, absolutely. And Akshat, I'm curious if you have any thoughts too. The main thing that that differentiates us from someone like Layer Zero or a Wormhole is that transactions that are happening now are happening on a protocol level. We're not using a sort of a social layer for the transactions for the cross-chain activity. We're exclusively using our protocol and the unified bridge on Agglayer. We have some really exciting features that are going to be coming in a couple months that will be able to introduce faster transactions that can communicate with protocols that are built on top of that. But the main differentiator is that the Agglayer is happening, all these transactions are happening at a protocol level. It's extremely programmable, and it's extremely deterministic in that way, where you can build an application and you know that it's going to run the code. You don't have to worry about a validator or somebody submitting a code and then someone else picking it up on the other end.
Just to add to Coogan's thing, I think also the most important thing is security. When we do cross-chain transactions, we think about security a lot. Pessimistic proof is something that enables that. Pessimistic proofs are ZK proofs that enable security when we do a cross-chain transaction. Agglayer Unified Bridge has these data structures called global exit route, local exit route, which properly deal with cross-chain transactions in a structured way. And then also there is pessimistic proofs, which are essentially ZK proofs that are submitted to the L1, which make sure that these transactions are secure. Because we already have seen many bridge hacks where people bridge assets from one place to another, but it's not secure. So security is the main thing that Agglayer offers.
And just another follow-up question on that. All of us have heard these terms, ZK proofs and optimistic proofs, or they are used in rollups as well. So Akshat just mentioned pessimistic proofs, so which are based on ZK proofs. So is this a different term just for ZK proofs, or it's something else? It's something new which is based on ZK proofs?
So it's a term which indicates what its basic what's function is. So pessimistic basically because we want to make sure that the transactions that are happening cross chain are secure. And what we want underlying technology that is built with this pessimistic proofs is SP1. We have a succinct SP1 prover, the ZKVM there, which uses Plonky 3, which is the Polygon's ZK proving technology, to make this possible.
As Akshat said, just a different genre of ZK proof. So ZK proof is an overarching term, and this is a specific one that we're using specifically for cross-chain security within the network itself. The biggest thing is that we have these also really great chains. I mentioned Katana, OKX, Immutable, these different chains. We have Terranova, these chains that are connected to Agglayer that are already doing this settlement work and already doing these transactions. So this is not something that is just being speculated or that we're using marketing terms. You can actually go out and do it now on testnet and mainnet. So this is live and available now. That's like sort of the conceptual reasoning behind Agglayer. I wanted now to shift to the actual developer portal itself. This launched yesterday, and Akshat and Brian from our team and myself have been working on this for quite some time, along with a ton of support from within Polygon as well. And it just went live yesterday. Really exciting because there are very few resources to help people understand how to do cross-chain application development. And we feel like we've developed really powerful tooling to be able to do it for Agglayer in an excellent way. So we want people to visit here. I'll just go through the site really briefly, and then I'll just walk through the install of Ag Sandbox, which is the main development tool that we have now, just to sort of show how easy it is. We can get your local development environment for Agglayer ready in under 5 minutes. There are a couple of prerequisites that you want to have on your system, but you really just clone the Ag Sandbox, you make it, and then you can start it in your local environment. And there's also fork mode that's available. And then as soon as that's spun up, which takes just a few moments, we'll see it in just a second, we can actually see the bridges that are available. We can see the events that start to happen, and we can start playing with these different Anvil instances. So for folks who are aware, we're using Anvil on the back end to create these 2 different environments, and then up to 3. There's also a multi-network option as well. And for each network, we have an Anvil instance, and the Anvil instance is running completely separately. And then those instances are speaking to each other using Agglayer protocol on a local level. We're able to skip some of the security pieces because this is just local development, which really accelerates the performance time, which has been a really critical piece of interoperability. And so it allows you to create these different applications that feel much more real time than you normally would get from blockchain applications. And what's exciting about that is that as we're rolling out fast interop on the Agglayer side, this will look a lot similar to the actual developer experience on testnet and mainnet now. So if you get ready now, you can be prepared for this mainnet launch, this production ready launch that we're going to be doing soon. So we have the kit here, and then you have examples, and Akshat has done an excellent job building these different examples. These will go all to these different repos here from Akshat, and we'll walk through one of the ENS demo today as well. These are integrated with the Agglayer sandbox on the back end. We built them for testnet, and we also are connecting them to the Agglayer sandbox as well. So this is a swap, so you can bridge a token from one chain to another, similar like on Uniswap. But rather than just being contained just to one network, you can actually swap across 2 different networks within the same transaction, which is pretty huge. Right now, you can only do those transactions in certain instances, and it's typically done with a mediated layer. This is something that happens on the protocol level, which is exciting and really interesting. We also have a cross-chain name service. This is if you have like an ENS credential, being able to use that credential and claim it on different chains within a network, and then being able to use those credentials across the multiple networks. It's a really powerful way to be able to sort of see how the user experience can also be abstracted and made universal with this interoperability piece happening under the hood. And then the last one is cross-chain lending, which is being able to collateralize assets and then borrow tokens on one chain. So you stake them on one chain, or you pull them on one chain, and then they're available on the other as well. These are examples meant to sort of teach people the design patterns
Oh, okay.
behind interoperability. Yeah, so they're not quite live. They're not live yet. What they're meant to do is just sort of show you what's possible, and as Akshat will sort of walk through, show you the different design patterns behind these different examples. So each of these we picked specifically because they highlight different design patterns, either doing like Uniswap, like Pool. The cross-chain name service worked a lot with ENS and NFTs, and cross-chain lending is just a DeFi primitive as well. So these are ways that developers can get really familiar with those patterns and then build their own examples and their own applications as well.
Understood.
To add on to Coogan, these are educational examples. We want to create this persona of cross-chain developers, which is upcoming now, and make sure that they know how the cross-chain design patterns work. So it's a little different from a regular blockchain development, and we want to make sure that we have ready-to-go guides, walkthroughs, so that people know exactly what to do and how to do, and it make it easy for people to locally host them, try it out, and then try it out on Ag Sandbox with their own demos, or might be built on top of the cross-chain name service, add more functionality to it. So it's completely for educational purposes. Yeah.
Yeah, even a demo like this where you show building something like this is actually possible. Someone can just go and build an actual live app for masses.
So we've actually integrated the Agglayer sandbox into our docs page as well. So I'm going to walk through just installing this. Now, this is like we're doing a live coding demo. So we have to pray to the live stream gods that everything works out, as it were. So I do have a backup just in case. Wanted to just let people know we're going to be walking through this quick start here. And I'll be walking through it on my local machine. And we'll be able to spin up Ag Sandbox really simply. So the main piece here is going to be, we're working mainly from the Ag Sandbox repo. So GitHub address is github.com/Agglayer/Ag Sandbox. And we need a few requirements. At first, we need to be running Docker. So I'm going to be running Docker here in the background. A Docker instance is going to be spun up. Docker is a really easy container management. You can also use Docker Compose. There's a GUI that you can install on your machine. That's what I prefer to use. You can also run it from the command line as well. And so I'm going to spin up Docker here. And while that's coming up, we also need Rust. So I'm sure a lot of the developers who are watching now are really familiar and have Rust installed on their machine, one of the prerequisites, and then make, which is typically on a Unix system. There's a make, and then Git just for cloning, which is really easy. So let me make sure my Docker is spinning up. Let's see here. Alrighty. So the main thing first, we're going to just sort of check that all the tools are here on the machine. Starting it here on the I'm joining here on my GUI. So yeah, good to know that it's here. So yeah, we'll start up the Docker Compose up here. All right. So we are going to first clone the repo here. So we'll clone grab this here from here, Agglayer Sandbox. And then we'll CD into it. And then first we'll do the make install here. And this is going to be installing the CLI. It's grabbing the latest release version, and it's going to grab all the different variables and things that we need from our repo here. This will take just a minute. Just while we're talking, there's a really extensive CLI that is included with the Ag Sandbox. And it's all documented within the repo itself. There are parts of it in the documentation as well as a really good FAQ and a quick start guide and all these different elements. There's a lot of support that we have for our documentation on our documentation side and on the GitHub repo itself. Sahil, did you have a question?
No, I was just going to say that they can find everything on build.agglayer.dev and then go to docs, right?
Yep, exactly. Everything is right here on the website, ready to go. All right. I might, let's see here, switch here. This is going a little bit slower, so I think I'll do this one here and then switch to Lion. Go. Exit box. Alrighty. Box. All right, perfect. And we do have a backup here. All right. All right, perfect. Alrighty. So we'll try again here. We'll do Docker running. So we'll do Docker compose up here. And while that's kicking up, we can run this over here, and we will do. So there are a couple of environmental variables. There are a lot of different configuration files within Ag Sandbox, mainly around the different networks you're going to be interacting with, the different RPC providers. And so we've made there's a .env file there, which you can look through and get a sense of the different variables. It's mainly around the different networks you're going to be targeting, as well as the different RPC endpoints. Let's see here. This is deploying our contracts here. So you can see this is the layer 2 Anvil session that is running up here, and then it's deploying a lot of the bridges and the sort of the Agglayer infrastructure as well. You don't need to know this. It's like it's sort of part of that conceptual piece. But it's just good to know that this is all being deployed real time, and it's going to be available. You will need to know some of them. Oh, and then here we go. So we're running. So the L1 and L2s are running. So we should be able to then here start up here. And when we start up here, we have, it just takes a few seconds. It's running, and then we'll just check the status here. Okay, so now we've been able to clone the repo, pull it down, start it up, and we can check that all the different services are running. We have AgKits running. We have 2 different instances, and we are able to see all the different accounts that we have. Like a really tricky part for developers is getting testnet faucets and having those run. But here, because this is Anvil, we have 2 sets of accounts that are here, and those are all pre-funded with 1,000 ETH. So you are currently, a millionaire for ETH in USDC. So now you have this environment and this rich setting in which to be able to start to build and to do things such as bridging assets, bridge and claiming on one side. You can verify all the bridging, all these different things. And then on the website, we walk through that actual process of how to do that. Overall, it just takes a few minutes just to get set up, and then you're ready to go on the developer side.
Just to add to Coogan, so when we did Ag Sandbox status, there's 3 services that are important. One's the AgKit, then there's the L1, and there's the L2. These are 3 services that start running. That's the main thing.
Once you have this environment set up, you can then start to build examples on top of that. And I'll hand it over to Akshat, because Akshat has built a really cool example, a couple of really cool examples, but in particular, the name service. So yeah, go ahead, Akshat.
Sure. Just to share the background here, Agglayer was live since the start of this year, but what's new now is the Ag Sandbox that Coogan just demonstrated. The time for cross-chain transactions to happen now, currently on Agglayer testnet and mainnet, is about 20 to 25 minutes. That is a bottleneck for developers to test out these cross-chain app ideas. So we at the DevRel team thought that it would be amazing if we can shorten the process so that we can make testing and building dApps for developers easy. So that was the basic thought process that went into when we started this out. And now we can do instant cross-chain transactions. There are 2 processes that go through. One's the bridging part, the actual bridging part, and then is the claiming part. So you send from, let's just say, an L1 to an L2. Bridge the transaction. There are 3 types of bridgings that happen. One is the bridge asset, where you transfer tokens. The second is the bridge message, where basically you can call any smart contract you want on the destination chain, as we call it. There's a source chain, which is the L1. There's a destination chain, that is the L. So we covered 2: bridge asset for token transfer, bridge message for calling the smart contract. Then there's something else called bridge and call, which is actually very exciting, which does both of these simultaneously. So you can bridge assets as well as call a contract. So what is the use case for bridge and call? We just covered cross-chain swap. Here are the templates and examples. So highlighting the build.agglayer.dev page again, where you can go and see these cross-chain examples. We have cross-chain swap here. You can read the description here. It says seamlessly bridge assets and swap them for another token in a single transaction. So we use Agglayer bridge and call here. And what we wanted to do is, the main problem in crypto today is the user experience. Usually, if we want to do a bridge plus swap, what we have to do is first bridge the tokens, then switch to the other network, and then we do the swap. So we want to do the bridge, then we switch the network and we do the swap. What bridge and call does is makes that into one transaction. We bridge, then swap instantaneously. So if we can go through the cross-chain swap, we have the source code, everything ready here so that you can clone them and get to know it. There are a few modules here, and there's a good readme, which is a walkthrough. As I told, it's mostly for educational purposes. We want people to go through each step and understand how the application side of Agglayer works. And also for people who are interested in the protocol side, Brian, who's the amazing DevRel at Polygon, who worked on the Ag sandbox that we are using now, made this amazing demo which is on his GitHub page called Agglayer Unified Bridge, where he explains the protocol side of it. So basically the data structures that are involved, how exactly behind the scenes the actual transaction is going through. And we are trying to simulate this using the Ag sandbox. So anyone from who's a protocol developer who's interested going in depth and going hardcore into Agglayer can refer this entire guide, which is an amazing guide from Brian, which will take you through the entire protocol side. But switching on to the application side where we actually have demos. When we started these demos, we wanted to make sure that we cover a huge horizon of fields. So we have cross-chain swap, which is DeFi related. And also we have cross-chain name service. We will have a few more coming, which is on the governance side, on the gaming side, just to make sure that we cover all fields and aspects of crypto. We have this cross-chain name service that I'm going to actually demo today, which is very interesting. If you have ENS today, or if you use ENS today, you can register your name on a single chain. And might be ENS recently came up with multi-chain names, but what you have to do there is switch networks and then register your name again. With Agglayer bridge and call or Agglayer bridge message specifically, because here we are just calling a contract, what we can do is in one single transaction, register your name on one chain and then bridge the details of the name to other chain, and then that will mint or like register the name on that chain as well. So in one single transaction, the UX of people who are using this app is going to be amazing, and we can get the names registered on both chains. This might seem a little, why do we need to just do it for two chains? But think of a future where we are connecting them to several chains, tens or 15s of chains, and with one click, your name gets registered everywhere.
I just have one question that for the normal traditional flow where a user will have to register the names on different chains, they'll have to go to that chain's naming domain service and then register the name, pay the transaction fee, etc., etc. So in this case, I know this is just an example, but how is the gas handled over here? Because you mentioned that once you send the transaction, the message will be sent to other chains as well to register for that particular domain or particular name on other chains as well. So how is the gas for those messages on other chains handled? Because obviously
Sure.
it is going to be a write operation on other chains as well, right? If I'm not wrong.
Definitely. Yeah, yeah. This is a very valid question. So I'll tell you what's currently happening and what we are planning to do, and the Agglayer team is planning to do as well. Currently, what we have is, so basically we connect the wallet. The same wallet is on the chain A as well as on chain B. So the
Okay.
chain B wallet tokens we have there will be sponsoring for the write operations. If we use bridge message, but there's something called bridge and call, which has something called a jump point contract. So if I can just share this here, there's a beautiful diagram that explains this completely. There's something called a jump point contract here, which comes and does the gas sponsorship for you if you use bridge and call. So when we do bridge and call on the destination chain, a new contract spins up, a new contract is created, and that contract calls the actual smart contract you wanted to call. So that takes care of the gas. And also, currently the Agglayer team is also working on something called a claim sponsor, which will
Okay.
basically take care of the claiming. So I said the two steps, there's bridge and there's claim. So the claim part takes gas. So a claim sponsor would be one who takes care of the gas for claiming and execution of the smart contract on the destination chain. Yeah.
So the claim sponsor would basically be a different smart contract which will be pre-funded, and then it will fund the other
Yeah.
smart contracts which will
Yeah.
actually register the domain. Got
Yes,
it.
that will be a service that will do that. But currently, if you also use bridge and call, the jump point dot sol contract will take care of the gas
You
sponsor.
can do it as well, like as so you can do it as a provider for your users. You can go ahead and claim, sponsor those transactions as well. So it's not
Mhm.
just contract call. It can be just a like the operator initiated as well.
So I'll show you the demo video right here, and I'll also have it host on the local host. So I'll go through that as well. I'm hoping that that works out, but I have this package ready. So basically, this is EggNS inspired from ENS. And then what we want to do is register a name. We press on register name. We first of all check the availability of the name on one chain. And then what we do is we register on Sepolia. This particular POC that we had done on testnet uses Sepolia and the ZKM Cardona network. So we register on Sepolia and then we bridge to Cardona. So what this does is Agglayer is registered on Sepolia and it's also registered on Cardona. Then we see that it's registered. Then we go to the My Name section where Agglayer is already registered on Sepolia. And then this is actually a time skip here. It takes about 20 minutes to actually go through. But after 20 minutes, available on two chains is shown there. But now we don't need to wait for that time. So what we can do with Ag Sandbox is do the instant claiming. So I'll just show you. Hopefully it works here. So I'll just try and register Ag Sandbox as the name here. And this is now connected with the local Ad Sandbox. The previous one was connected on the testnet. This is connected to Ad Sandbox environment that is running over here. So basically the same steps. First check for availability, then you do a registration, and then basically you bridge to Cardona, which is the chain that is spun up. Let's just say it's a local chain spun up using Ag Sandbox. This part is completed now. To show the actual demo here, so we are in the terminal. I'll clear things up so that it's visible for everyone. So what we have now is, this is a contract. So I'm highlighting it here. This is the registry contract on L2. And we're checking a function called name exists there. I just checked it out earlier with some other name. But what I'm going to do now is put in Ag Sandbox, which is the name that we just registered. Remember that we have not yet claimed the transaction. So what we expect to happen here is that we get a 0. Yes, we get a 0, which means that the name does not exist, Ag Sandbox, yet, because we still didn't claim the transaction. What we want to do now is, if you go to the Ag Sandbox documentation, there is command scope bridges. This basically takes into account all the bridge transactions that are happening. And previously we had 4 bridges. I had tested out 2 transactions before. So hopefully it should show 6. Yes, it's showing 6, which means that the transaction went through. The bridging registration, it went through, and we have 6 total transactions. You might ask why 6. I recently told that bridge call handles 2 things, bridge asset and bridge message. So those are counted as 2 separate transactions. So I tested out 2 transactions before, which makes 4. And then 2 others are the newest bridge asset and bridge message. These are all the metadata details of the transaction. Then I'm going through and searching for my transaction here. So if you can see the deposit count here, it's 5. So it goes from 0 to 5 for 6. And this is the exact transaction that we did right now. So I'll just put it over here for reference. What we're going to do now is claim. As Coogan just installed, this is the Ag Sandbox CLI that I'm using, and using all the different commands to basically drive the sandbox environment. So this is the previous transaction hash. I'm just going to put my new transaction hash that I just did, and then I'm going to claim. So earlier I had actually pasted the wrong hash. So I've pasted the correct one now. It's claiming it. So we have claimed transaction. So the 2 parts, there's the asset. So it's claiming the asset first. So we did both these things. We claimed the asset. We also claimed the message. Now, what we should observe is that the name that was previously unregistered be registered. So I'm going to run the exact same command over here, and hopefully it is registered. So you can see a 1 over here. There was previously a 0, which means that the cast commands, the annual commands that I'm using to basically check if Ag Sandbox, the name was registered, is registered or not, and it is registered. The entire demo, what we did is we bridged, we transfer that data of Ag Sandbox to another blockchain, and then the contracts. We did the bridging side on the UI on the front end side. We claimed the transaction here using the Ag Sandbox CLI. And then we also checked that whether this actual name is so the complete workflow works. So I hope that it was hopefully actually good thing that everything was. the Axon box is very safe, and it allows you to do multiple iterations of testing. We have tested this internally a lot, so hope that there is nothing issues with it. And if there are any issues as well, you can reach out to us on the GitHub issues side, where we can might be cater to those issues and fix those bugs.
And for those of you who are wondering, like where I can access the Agglayer sandbox tool or how I can get to these examples, so if you want to get to these examples, you can just go to build.agglayer.dev and go to /examples or just click on examples. That's how you can go to these examples. And if you want to go to the sandbox tools, you can see that over there on the screen as well. And if you even don't want to do that, we will have all of these linked.
And just thank you so much for having us on here, Sahil. I know that QuickNode has a great community and people who are excited about Web3 and crypto development. And so we'd love for you all to jump in and try out these tools and give feedback on these different examples.
Awesome. Perfect. So I think on that note, we can end the stream here. I would really like to thank both of you, Akshat and Coogan, for coming onto the stream and walking us through Agglayer and the new developer portal. Thank you so much, guys.
Awesome. Thank you. Really appreciate it.
All right. Thanks everyone who's watching us, and we'll see you in the next one. Bye-bye.